Hi, I'm Tim Hewer, and I'm a product manager at Microsoft on the .NET team. My team builds a lot of the tools .NET developers use in Visual Studio. Today, along with team members across Visual Studio and .NET, we are going to show you how you can build real-world native client apps with .NET, Visual Studio, GitHub, and Azure, and why this combination of tools and services provide the best experience for building applications for any device. You can build anything on .NET. We've made significant investments in .NET over the years, as well as unifying the platform to support building literally anything. From desktop apps to games to the cloud, you can build all kinds of applications with .NET. You can use one developer platform, one language, and one set of standard libraries for building anything across operating systems and devices, and your apps will perform great. With Microsoft Azure, we provide a cloud infrastructure that helps you develop these applications. We also have productivity tools with Microsoft 365, business applications with Dynamics 365, and the Power Platform to connect your employees and your business processes to your custom applications. And we have a great set of professional developer tools and services with Visual Studio and GitHub. You can code from anywhere with cloud-powered development environments, collaborate smoothly with tools that help you work as a distributed team, and securely ship from anywhere with fully integrated services and tools. No other cloud vendor offers this fully comprehensive developer experience. Developers love Visual Studio, and particularly Visual Studio 2022 that we released last November. Comparing the first 5 months since release with Visual Studio 2019, VS 2022 is on a great trajectory with over 1.6 million more downloads than Visual Studio 2019. Simply incredible. We also released .NET 6 in November, and it has become the fastest adopted version of .NET to date. We've seen this for 3 .NET releases now. The new version is adopted faster than the previous one. But to see almost double the amount of active monthly developers in the same period since release compared to .NET 5, and this is developers actually coding with .NET 6, that is just amazing. In fact, we see over 5.5 million total active .NET developers monthly in the Visual Studio family of tools. Thank you to everyone, developers and open source contributors, that have made this release such a success. As a recap, here are some of the features of .NET 6. You now have a unified set of common base libraries and SDK. So no matter what type of application you're building, you have access to the same standard libraries and developer tools. We continue to make improvements to the performance of .NET and top the Tech Empower benchmarks. Hot reload technology helps you build apps faster, and we've enabled it in the CLI and Visual Studio. We strive to make .NET easier to get started with simplification features like minimal APIs and C#10 language enhancements that help you reduce the amount of code you have to write. If you haven't already, download it and get started today. Now let's talk about modern client app development and how important it is. There are a lot of desktop and mobile devices in the world. There are over 1 billion Windows 10 and 11 devices worldwide, and over 4 billion iPhone and Android devices, and these numbers will keep on growing. Regardless of if you are a web developer or a native app developer, you want to reach the most client devices possible with great user experiences in the most efficient way possible. In order to reach all of these devices with beautiful app experiences, we built .NET Multi-Platform App UI, and I'm happy to announce its release. .NET MAUI is the most productive way to develop native apps that perform great on any device that runs Android, iOS, macOS, or Windows from a single code base. Instead of learning different stacks and languages for each device, you can use one language, one set of libraries, and one UI stack for them all. APIs are available directly from C# to access over 60 device platform features, including things like isolated storage, sensors, geolocation, camera, and more. Use one programming language, one code base, and one project system for all device targets, with support for cross-platform resources, including images, icons, splash screens, and more. .NET MAUI on Windows supports WinUI, allowing these apps to use all of the newest native features on supported versions of Windows 10 and 11. The development tools remain in preview, but will release soon. You can install the .NET MAUI workload from the Visual Studio 2022 preview channel. .NET MAUI is built on .NET 6, so that means that you get a single, unified .NET experience across workloads and project types. There is one base class library and unified type system with CLI support. It also falls under the same support policy as the other components of .NET 6. .NET MAUI under the hood uses technologies out there today for building native apps on Windows with WinUI, Mac Catalyst for macOS, and of course, iOS and Android. .NET MAUI abstracts all of those frameworks into a single framework built on .NET 6. .NET MAUI lets web developers build hybrid web apps too. Share Blazor web components directly in .NET MAUI apps while having access to native device capabilities and packaging. By using .NET MAUI and Blazor together, you can reuse one set of web UI components across mobile, desktop, and web. Visual Studio 2022 includes hot reload technology to make you much more productive building .NET MAUI apps. Type code, hit save, and see the changes right away. You can also take advantage of the latest debugging, IntelliSense, and testing features of Visual Studio to write better code faster. We built this .NET Podcast sample app that spans web, mobile, and desktop, cloud-native backends, and more. We wanted to build a realistic scenario of a consumer app. Consumer apps need to be beautiful, responsive, and full-featured no matter what device someone is using. We're going to show you how .NET 6 and MAUI enable you to do this today. You can get all the source code for this app right now on GitHub. This is the architecture diagram we'll be going through most of the pieces in our demos throughout this session. In order to have the widest reach with the best scalability, we also have implemented the backend with a microservices architecture deployed in Azure. First up, we'll begin with the mobile and desktop client apps. I'd like to have Maddie come up and show you how you can build beautiful native apps with .NET MAUI.
Thanks, Tim. Let's take a look at how you can get started right now with .NET MAUI development. So first and foremost, you want to be on the preview version of Visual Studio. And if you go to Modify or when you're installing it for the first time, either way, you are going to want to check off the .NET Multi-Platform App UI Development Workload. That's us. That's MAUI. And that has everything you need to get started with your mobile and desktop app development using .NET MAUI. So I've already gone ahead and created a new project. We could file new if we wanted to, but I'm not going to. I have this beautiful project, MAUI App 1, already up and running. And this is our template MAUI app. And it's pretty simple. So if we look at our Solution Explorer here, you can see that there are just folders for all of the platforms we target. So Android, iOS, Mac Catalyst, Windows, and in this one we also have the Tizen folder if you want to target any Samsung-specific devices. And if I open the Android or iOS folders, you see that there are all the platform-specific files I need to run on that device. So you don't have to look at them. They're tucked away. They're all hidden in there. But everything you need to deploy to all four of those platforms is right there. If I look in this resources folder here, I've got a couple different things going on, but most importantly, I have a folder of fonts, all the fonts I have in my application, a folder of images, and a folder of raw assets, and then a styles, which we'll look at in a little bit. In my project file here, so if I right-click here and hit Edit Project File, my CS proj file, I can see all the frameworks I'm targeting are actually listed out right here in my XML code. So Android, iOS, Mac Catalyst, and Windows. And then all of the metadata of my app is also set here. So my app title, MAUI App 1, very creative. My app version, all those different things are all in here. Another really cool thing about .NET MAUI's single project is that you can create shared icons and splash screens for all the different platforms very, very simply using just SVGs. So you saw in my resources folder here, I had app icon and app icon FG for foreground.svg. In my CS proj file here, I set those as my MAUI icon. So my app icon, it just says .NET, nothing fancy. My app icon foreground. And then the background color is the beautiful .NET purple. Same thing with my splash screen. And so when I go to run this app, That's what it's going to use as both my icon and my launch screen, my splash screen there. So if I go into my target framework selector, that's what we call this thing up here, you can see I can click between all these different things here. It's wonderful. And so what I'm going to do is not deploy to my Android emulator here. I'm actually going to go and do something kind of cool and deploy to this blah, blah, blah Microsoft Corporation subsystem for Android, which is the Windows subsystem for Android running locally on my Windows 11 PC. So this is a new feature. It's available for Windows 11 developers in the United States. And what it's going to do is actually run the Android app as if my Windows device is the Android application. And you can see I have that beautiful .NET purple launch screen with my foreground icon being that .NET logo. We're going to give it a second to launch. And then we're going to see my sample app pop up right here running locally on my Windows machine using the Windows subsystem for Android. Cool. And this is my MAUI app. It's pretty simple. It just says, hello world. Welcome to .NET Multi-Platform App UI. And I can click it a few times. Pretty exciting. Got my little .NET bot here. I'm actually going to stop out of this. Let's stop debugging. Great. And let's switch this over to our Windows target framework here. So I'm just going to click Windows, let it pop up on my Windows machine, and deploy. And take a look at the same app running on Windows. So this code is just XAML and C#. It's nothing fancy. We've got some labels, buttons, images, and our C# code behind has our button clicker counter, right? On button clicked. And so this is the same code that runs on all of the platforms that MAUI runs on. We're going to give it a second to spin up. And it's launched on my other monitor, of course. Let's look at that. Close out of the Android one. There we go. And I'll drag this over. So it's pretty much the exact same app. There is one difference. This title bar is a little bit different. We'll compare and contrast those in a second. But it's the same app, same code, same images, all that good stuff, all using .NET MAUI. Now, it's kind of a pain to demo this with the app kind of on top of Visual Studio. So what I'm going to do is hide my diagnostic tools window and open this new tool we have called XAML Live Preview. Drag it open so you can see it, and then fit with here. This is the same app now. This is just this app. Oh, not that one. This one. It's just this app, but it is screen mirrored basically into my Visual Studio instance so that I can see it within my single monitor and start making edits and see those edits reflected live in my running app. And of course I have to pin it. I have to not forget to do that. Drag it back out. There we go. And then I can start changing things here. So let's change this scroll view here to have a background color, right? Let's just say background equals purple, right? Doesn't look great, but you can totally see it changed right away. Didn't have to save or anything. And that is XAML Hot Reload working its magic. I can just undo all that. And let's say I wanted to find a specific part of my UI. I can use what's called the live visual tree here. Open this up. Let me just shrink this a little bit. Boop. Open my app. And when I highlight over all these different elements in the live visual tree, it actually shows me in my running Windows application where those things are, what they're encompassing, right? So it makes it really easy to debug my UI. So if I want to find out where exactly this button is in my code, I can highlight over it, it'll highlight it in my app, and then I can click these two little carrots here, click on it, it takes me to the button. So then I can go ahead and change my text around, do whatever I want, right inside my XAML. Really, really easy to get started changing and editing your UI while the app is running. Now that's just XAML. We can also change our C# code while the app is running. So let's go look at this button clicker here. Let me just fit this to height so it's a little bit clearer so we can see it. And we'll unpin this because we don't need it anymore. You can see this is a counter here. It says count plus plus. And so if I click on my running app over here, if I click it, get it up to, let's say 6, it's just incrementing by 1. So what if I wanted to change this to count plus equals 2? And then I'll hit save, and this will trigger a XAML Hot Reload. And when I go back into my app here and I click it, now it's just going up by 2. That's that. Pretty cool. So this is the Windows app. We looked at the Android app, and I'm going to pull it back up so we can compare something quickly. And I'm actually going to pull it up on my emulator here. So I pre-deployed it. I'm just going to open it. I'm not going to start debugging this one. Same launch screen that we set in code. And you can also see the icon. You know, if I pull this Windows app back into my main monitor, the icon is the same, the little .NET. And let's talk about why this title bar here is different. So .NET MAUI uses the native controls under the hood, which means that this button on the Android device here, on the Android emulator, is an Android button styled to look the exact same as this Windows button here, which is also styled. And we did that all, if I unpin my live preview and I open my Solution Explorer, in my styles.xaml file. So we actually give you in the template a really, really nice in-depth styles file that by default will make everything look the exact same on both platforms, whether it's in light or dark theme. So we styled the buttons to be purple with those pretty rounded corners, lowercase font, white text, whatever it is. We styled the labels to be those different sizes. And if I pull back up my Android emulator, you see what I'm talking about. But this navigation bar here, we actually didn't style. This is set in something called shell, which is the container of your application and handles all the navigation. So this shell is really, really basic. It's just a title that says hello world, and the platform, the native platform, does the right thing to show how a title is. So on Windows, if I switch back to live preview, it's just white with black text. On Android, it's actually using purple text. It's using the accent color of my application from the top when I drag it down here as well. And if I wanted to add tabs or flyouts or anything, I could do all of that right here in my shell file. So it's using the native controls under the hood. It's styled to look the exact same. And all of my navigation assets, everything are set in one place. This is a pretty basic application, though. Let's take a look at the podcast app that Tim talked about a little bit earlier. Pop it up here. And I actually already have this deployed to my Windows machine, so we're not going to try and debug it right now. I'm just going to turn it on here and drag it over. And so this is my .NET Podcasts app. You can click into these podcasts. I can see all the episodes of it. This .NET MAUI podcast sounds pretty cool, if you ask me. I don't know. And I've got all these different pages, settings. I can actually turn on and off dark mode, and it updates immediately as the app is running. Very cool. And this is all on Windows. But again, it's the same shared code base that I have with .NET MAUI. So I have those same platforms and everything. And what I want to do is actually run this on my iPhone here. So I have an iPhone. It's plugged into my PC. I'm signed in with an Apple developer account. I'm going to hit the debug button or F5 or whatever you want to do. I like to hit the button. Feels a little bit more tangible. And this is actually building and deploying this app into my iPhone right now without a Mac in the loop. So, as using an Apple developer account, it's a paid Apple developer account. This is for development only, not for distribution of the apps. But for developing, if you have an iPhone and you don't have a Mac right now, this is a great way to get started using .NET MAUI and testing out your apps on all the different devices, such as your physical iPhone. So while this is bundling, we're going to give it a second. It's thinking about it. I unfortunately cannot screen mirror my iPhone. So you're going to have to look at my video here, and I will show it to you in my webcam. But it says my app's been installed successfully. It's reloading it. It's going to ask me to launch it. Great. I'm going to click on it. Same launch screen, if you can see that. Very exciting. Give it a second to load. Yay! There's my podcast app. It's the same one. And I can scroll around. I know it's hard to see it. I'm sorry. I can click in to the .NET MAUI podcast, see all the different episodes there are, and scroll through those. And this is just debugging. So, of course, I have the amazing tools I'm used to, such as Hot Reload. So if I change my background color here to pink of my grid, give it a second, it reloads in my iPhone. Pretty cool, right? Hopefully that's in focus. Pretty cool. So that's 3 of the 4 platforms. Let's actually flip over. I have my Mac up and running here. Here's my MacBook. And let's take a look at the same app running on Mac Catalyst, the 4th platform that .NET MAUI targets. So this is VS or Mac 2022, rebuilt from the ground up to run on .NET 6. And I hit the debug button, and it is going to spin up the same code base, the same podcast app we just saw on Windows and on iOS here natively on my MacBook. It's got the same features. I can click in my podcasts. I can go flip on dark mode, of course, using my one MAUI codebase. So that is really the magic of .NET MAUI. One codebase, all of these different operating systems and devices, Windows, Mac, Android, and iOS, all using .NET and C#. So I'll send it back to you, Tim.
Thanks, Maddie. That was great. Now let's talk about web development with Blazor. Blazor lets you write full-stack web apps with C# instead of JavaScript, and it has become very popular. It has supported two models, Blazor Server and the other, Blazor WebAssembly, which runs completely in the browser. Blazor has a shared component model across the server and the client browser. Depending on your application needs, you can choose the right model for you. With the release of .NET MAUI, you can now add native capabilities to your Blazor apps. This means you can create hybrid client apps which combine web and native UI technology together in a single native client application, so you can build rich client and offline experiences. Blazor hybrid apps are built on top of .NET MAUI. It relies on that UI stack for a native application container and native controls should you want to use them. Blazor hybrid apps have access to the machine. You can do things like call native APIs, access the file system, write multi-threaded applications, all with the high performance and optimal memory consumption you get with .NET. Let's hand it over to Dan Roth, who will show us some of the new features in Blazor.
Hey folks! Blazor is a client web UI framework for building rich interactive web UI using .NET and open web standards. Blazor is part of ASP.NET Core and the .NET platform, so you can build full-stack web apps with just C# and .NET, no JavaScript required. This solution contains the .NET Podcast web app, which is completely implemented with .NET and C#. Let's get it running. This is a beautiful modern web app that looks great on both small screens and big screens. This home screen is server rendered, so it's generated on the server using Razor Pages. But the podcast player, this is completely implemented using Blazor. Blazor web UI components implemented in Razor and C# that are executed from the browser using a WebAssembly-based .NET runtime. The player has a rich interactive UI. We can search for podcasts. Let's select a show. We can play an episode. Oh, we've got in-browser playback. Sounds great. I'm definitely going to want to listen to this one later. So let's go ahead and add that to our listen later list, and it shows up on the appropriate page. We can also play around with the settings. Let's turn on dark mode or light mode. And there's even this really cool listen together feature where I can listen to a podcast with a friend. Let's create a room for this podcast. I'll type in my name. And then normally I would send this code to a friend, but just to simulate that, I'm going to duplicate the tab and then add the name of my friend. Happens to be Dan as well. And now we should be able to listen to this podcast together. Let's go ahead and snap this side by side, and we can play the podcast in real time. It's synchronized, and we can send our reactions to each other using emojis. Super duper cool. So with Blazor, we've got a web UI built completely with .NET and C#, and it looks great. But sometimes building a web app isn't enough. Sometimes you need full access to the native capabilities of the underlying platform. In short, sometimes you need a native client app. If you're a web developer, building a native client app may seem a bit daunting. Fortunately, with Blazor and .NET MAUI together, it's now easy. Blazor integration in MAUI lets you use a hybrid of web and native capabilities. Let me show you what I mean. Let's go back over to Visual Studio. MAUI has Blazor integration built into the framework, so you can use Blazor web UI components from your .NET MAUI apps. Your Blazor components run natively in your app along with the rest of your .NET code. No WebAssembly needed, and they render to an embedded web view control. .NET web developers can get started with .NET MAUI and Blazor using this provided template. This template creates a normal .NET MAUI app with a Blazor web view control already set up to render your Blazor components. You can then define your components using Razor syntax. So let's go ahead and look at this MAUI project. Let's go into mainpage.razor. There's the Blazor web view control. This is what we're going to use to render our Blazor components in our app. In this case, it's going to render main.razor. We're using Razor components directly from .NET MAUI. Awesome, let's get this running. Now we have our Blazor components running in a native Android app. They work great. We can run on Windows too. And now we've got a native Windows desktop app running our Blazor components. Native desktop and mobile using Blazor. As much native or web as you want. You can also use existing Blazor components in .NET MAUI Blazor apps. For example, let's add a Razor class library to this project. And then in this library, I've got a simple component. It's just a div. And in order to use this component from my .NET MAUI project, I just reference the project. And now I can go into the homepage, index.razor, and add the component right there. Let's just type in component 1. There we go. And now when we run the app again, we can see our existing Blazor component being used from the desktop application. We can go even further and take a whole .NET web application and turn that into a .NET MAUI app. Let's go back to the .NET Podcast web app. Let's add a .NET MAUI project to this solution. This is an existing project that I have already set up. It's already got a Blazor WebView control. And that Blazor WebView control, again, is going to render the main component. That main component is now going to render the pages from our Blazor web application, podcast.pages, the same project being used by the web app. If we now run this, we're going to run the .NET MAUI project. We can see it running on desktop. There it is. And of course, it runs on web. And now it's running in a native Android application as well. The same Blazor web UI components being used on mobile, desktop, and web. Because it's now a native client app, we can also now use native client features. For example, instead of using browser-based playback, we can use the native system audio. For example, on Android, by using the underlying platform audio playback features, hear the audio, sounds good, but we also now get like the little audio widget that shows up in our Android settings pane. We can see how this is set up in the code. Let's go back to the solution. In MAUI program.cs, if we scroll down here, we can see all of the native audio service implementations for each of the various platforms. By using Blazor with .NET MAUI, we're able to share our web UI across mobile, desktop, and web. There they all are. And then we can also use native platform features as well. Oh, look, there's Maddie calling me now. Let's see what's up. Hey, Maddie, what's going on?
Hey, Dan, hope I'm not interrupting anything, like, I don't know, your build demo, but I saw that you had added some Blazor code into my MAUI app, and I just wanted to know what you were doing there. It seems like pretty cool.
Yeah. So I saw that in the .NET MAUI app, we didn't yet have that listen together mode. So what I did is I took the Blazor components from the web app, and I added them to the .NET MAUI application.
Cool. And can you, if I share my screen, will you just show me like what you did in the code to make that work?
Sure, let's take a look.
Sweet. All right. Let me just share it. Okay, cool. Here we are. Where did you add this?
So if you go to the Listen Together page, you'll see that I added a Blazor WebView control, and that's in XAML.
Cool.
And what that does is that will render the Listen Together Blazor Web UI components from the web application.
Oh, okay, cool.
So it's literally the same components. Like if you look at the project references, you will see that your .NET MAUI app now references the same Blazor component library that we're using in the web app.
Oh, that's awesome. And so we're using the same functionality just in native on the desktop, but also on the web, even though it's
Native
the same code
UI,
in both places.
Web UI, both together in the same application. That's right. Do you want to give it a try?
Yeah, let's do it.
Okay. I'm going to create a room on my screen to listen together and type in my name. All right. And we'll open a room. And then I'll send you the code for the room in the chat so that you can join. Once you get the desktop app running, you can type that in.
XH.
And I see you just showed up. There you are. Okay. And so now I'll start the podcast and we can listen together.
Great. Good podcast choice, by the way.
And we can send each other emojis, some thumbs up, some hearts, share the love. Yeah, I see yours coming my way too. So this is showing how we can take .NET MAUI and Blazor and use them together to build mobile apps, desktop apps, and web applications using as much native UI and web UI as we want.
That's awesome, Dan. Thanks.
Very welcome.
Thanks, Dan and Maddie. That was awesome. As you can see, you have choices when it comes to native and web development with .NET. It comes down to reach and power, and it's a sliding scale. Depending on your application needs, you can choose the right mix for you. Full web for the most reach, full native for the richest native experiences, or a little bit of both for hybrid. I also want to call out that many .NET ecosystem partners have controls and components available today that add functionality and provide advanced controls for your .NET MAUI and Blazor apps. We have an awesome ecosystem. Please go check them out. Now let's take a look at some of the tools that make you more productive building any app with Visual Studio 2022. Released in November, Visual Studio 2022 is the best IDE for .NET development. With support for the latest project types for cross-platform mobile and desktop apps with .NET MAUI, as you saw in Maddie's demo, and responsive web UIs with Blazor, as Dan just showed you. You can build, run, and debug .NET apps in Linux environments with WSL integration, and there are a lot of new and improved tools for working with Azure. Visual Studio helps you stay productive and collaborate with hot reload everywhere. IntelliCode, which is smart IntelliSense with whole line completions and suggestions for common code refactorings on the fly as you type. Built-in Git and GitHub integration to clone repos, manage work items and pull requests, and automatically set up CI/CD workflows to GitHub Actions with Azure. And VS 2022 is the first 64-bit version of Visual Studio, so it can take advantage of the full power of your dev box to work on projects of any size and scale. If you haven't already, go download it today. Thank you to all of the thousands of Visual Studio extensions that have supported Visual Studio all these years. We know it was a challenge to update to Visual Studio 2022 64-bit, and we're thrilled to have you continue in the developer journey as valued ecosystem partners. What's next for Visual Studio? We're excited to announce that the upcoming release of Visual Studio 2022 17.3 Preview 2 will include native support for Windows 11 on ARM64. This will be the first version of Visual Studio that will natively support building and debugging ARM64 apps on ARM-based processors. Our key goal with this preview is to introduce and stabilize the most popular ARM64 developer workloads, and to gather feedback from the community to help us prioritize additional experiences moving forward. Initially, we will support C++, .NET Framework, and .NET 6 desktop projects. You'll see support for more project types in subsequent previews. Visual Studio 2022 17.3 Preview 2 will be available in June. As for running apps natively on Windows ARM devices, we first introduced support in .NET 5. Now, .NET 6 and .NET MAUI apps are supported running on ARM. You'll also see support for ARM coming in .NET Framework, which is a component of the Windows operating system, in the upcoming version 4.8.1, and is available on the Windows Insider Preview channel. Now I'd like to hand it over to Leslie, who will show off some of the new tools in Visual Studio 2022.
So Maddie and Dan have been working on the MAUI and Blazor components of the podcast app, but I've also been putting my own finishing touches into this app as well. So let's take a look at some of the final tasks that I need to do before I ship with the help of Visual Studio. So the first thing that I need to do is create a podcast restart method. You'll notice that as I start typing, I'm already getting some support from IntelliCode to write my method quickly. So thanks, IntelliCode. And even better is, as I continue typing, it turns out I don't even have to spend time thinking about how to implement the nuts and bolts of this method, because the new AI-based coding assistant in Visual Studio can do all that work for me based off of my existing code base and thousands of open source repositories in GitHub. So once I boot up my app, everything's looking great, except no, I left the dreaded typo on the landing page of all places. So now I got to go back in Visual Studio and see if I can spot my spelling error. So I'm going to use the new code search experience to quickly locate what I'm looking for. It is now faster than ever, and it can give me instant results as I type. And once I'm on the landing page, usually this would be the point where I need to find my own spelling error through my own manual means. But now you'll notice that Visual Studio's new built-in spell checker automatically gives me that famous red squiggly that's similar to other Microsoft Office tools. So from there, all I need to do is use the light bulb and replace the misspelling with the correctly spelled word. And with the addition of hot reload on save, I just need to save my file. And as you can see, that update has automatically been changed in the landing page. So talk about a smooth workflow. So my app's looking pretty good on my desktop, but I honestly spend way more time browsing the web on my phone. So I'd love to debug and test this app on a physical phone before I actually deploy it. Well, if we zoom in on the URL, you'll notice that I'm not using the usual localhost server, and that's because I'm actually using a visualstudio.com hosted port tunneling service that allows me to access my localhost from anywhere, including my phone. So I'm going to take a picture of this QR code from an extension that I've got in order to access the URL. And bam, as you can see, I got the website on my phone. It's being port tunneled from my desktop to my phone without having to have any cables or apps installed. Pretty sweet. So this app is taking in a large list of podcast data, and I want to make sure that all of that data is being loaded up properly. So lucky for me, port tunneling lets me debug from my phone to inspect that data. So back in Visual Studio, I'm going to set a breakpoint. And I'm actually going to set a temporary breakpoint because I only want to use this breakpoint once. It's going to be one and done, and it will automatically delete once it's been hit. And from there, I can go back and refresh the page. I'm going to do it on my phone, and you'll notice that the breakpoint has been hit, and also the breakpoint itself has disappeared. So I don't even have to worry about remembering to delete it afterward. And it's those little wins like that that really add up to make my development experience so much more productive. Now, the icing on the cake here is that because I am looking at an IEnumerable list of podcast data, I can inspect it with the new view button that I can click right here. And I can get a tabular representation of all of my podcast data. It's like being able to inspect a table in Excel, and sure enough, I can even export this table to Excel to further inspect and manipulate the data to my heart's content. And those are just a few of the many awesome enhancements that Visual Studio has recently added to make our development environments more productive, customizable, and expansive. So thanks a lot, and back to you, Tim.
Thank you, Leslie. You saw Leslie show a feature we're working on called port tunneling. This is when you may want to debug a backend API from a mobile device, say, in your hand. The challenge is your mobile device isn't communicating with your local development environment running on your local machine on localhost. To help solve that problem, we're building a feature where we can enable port tunneling directly from Visual Studio. This enables developers to have public endpoint that tunnels down into their machine, giving them seamless debugging for mobile applications, Power Apps, webhooks, Blazor apps, and more. With just a couple of configuration settings, you turn it on. It's currently in private preview. Sign up and give it a try and provide feedback. You likely can't have a client application without a backend to support it. Let's drill into some of the capabilities of Azure and how we can use GitHub to help us get our code to the cloud. No matter what Azure service you use, you can be confident that .NET is supported. .NET 6 was supported on Azure the same day of its release in November last year. Azure App Service support for .NET 6 is available in all regions for both Linux and Windows. Azure Static Web Apps support full-stack .NET 6 apps with Blazor WebAssembly and Azure Functions. Azure Functions support for .NET 6 is available in Azure Functions Runtime 4.0. Both the in-process and isolated models are supported in .NET 6 Azure Functions. Going forward, you can expect .NET releases will be supported on Azure the day it's released. No matter what type of cloud app you're building, .NET and Azure have you covered. A very common pattern is, of course, N-tier. These apps are typically simpler to build, work well with smaller teams, and are deployed all at once. ASP.NET has many features to help you build beautiful, scalable web apps based on this pattern. Another common pattern is the microservices pattern. It enables rapid, frequent, and reliable delivery of large, complex, highly scalable applications. Each loosely coupled service can be independently deployed and owned by separate teams within an organization. Azure Container Apps aim to make building microservice-based applications a lot easier, and the service is now generally available. Container Apps is the only serverless container solution offering a combination of built-in HTTP-based autoscale, including scale to 0, and event-driven autoscale to run containers that may be processing messages from queues, streams, or databases. Container apps support microservice architectures built with containers using any language, framework, or runtime. And they provide a streamlined code-to-cloud pipeline using GitHub Actions. Container apps abstract away Kubernetes and let you focus on building apps instead of managing infrastructure. It lets you perform modern application lifecycle tasks such as application upgrades, traffic shifting, and versioning ready to run for teams of every skill set. Container apps are perfect for microservices built with .NET 2. Whether you're building ASP.NET Web APIs, minimal APIs, or using the worker service template for background services, container apps can run them seamlessly. You can also deploy them to container apps with Visual Studio 2022. Visual Studio is part of a larger solution that enables you to focus on apps, not infrastructure. With Visual Studio, GitHub, and Azure, you get a seamless experience from code to cloud. Using your favorite languages and platforms of your choice so you can securely code, collaborate, and deploy applications anywhere. Let's take a look at our diagram again and focus on the back end. As you can see, we're taking advantage of Azure services here, particularly Azure Container Apps for our microservices. Let me take a moment now to show you how Visual Studio and GitHub combined help you get your code to cloud quickly, with some additional new helpful capabilities in GitHub Actions as well. As we mentioned, looking at the podcast architecture, we have microservices that power different parts of the app. We want to deploy those to Azure using the new Azure Container App Service for container deployment with awesome scaling. VS 2022 helps you get your services to Azure quickly. From the podcast app here, I can choose to publish the service and see all the different options VS provides me to deploy from direct to servers, container registries, and many Azure services. The new Azure Container App Service is available for me as a deployment endpoint. This enables me to quickly push updates. Of course, our app is already on GitHub, and Visual Studio helps me create a GitHub Actions workflow for the same deployment quickly. And that's what we've done here for enabling streamlined CI/CD flow for build and deployment of our entire app. After seeing Leslie fix that spelling error, I wondered, hey, did I have any of those spelling errors? It turned out I didn't, but I was able to make my logging messages more clear inside the various server applications. However, I also put Leslie's fix in for her since she forgot to commit her work for the repo. In fact, if we come over here and take a look at the web browser, you'll see that currently we still have that spelling error up in our environment. So what I'm going to do is go back into Visual Studio, and I've got a bunch of changes already set up and ready to go. And so I'm just going to go to the Git menu, and I'm going to push these up to GitHub. Now when I do that, Visual Studio is going to get ready, and it's going to send it to GitHub. And wait a minute, notice what happened. We're using a new feature on our repo, which is a part of GitHub Advanced Security called push protection. And what's happened is that it's detected that I must have left a secret in one of my files that I committed. And I can already envision what I did. There's a couple ways I could work this out. And one way is right away with Visual Studio, we have this great feature that was added in Visual Studio 17.2. The ability for me to compare a local branch with another branch and see the differences between the two of them. So if we come over here to my tab, here we can see my repository, and I can right-click on main and select Compare Feature Update with Main. And this will show me all the different changes, like the update I made for Leslie to get rid of that spelling error. You'll note that I can look at my worker files and see the changes I've made. And sure enough, we can see that I've left a secret in my app settings file. Now there's a couple of ways to deal with this. One way is I could go up into GitHub and I could provide it with a URL that tells it whether it was a secret that's used for tests, a false positive, or something that'll get fixed later. But I know exactly what I did wrong here. So what I'm going to do here is I'm going to go back to my history and I'm going to jump over onto my feature branch here. And I'm going to right-click on this item here, and I'm going to tell it to reset and delete that change. I'm not going to even put that up there at all. And so we'll give it a second, and now I feel more confident that it's okay for me to push this up there. So let's go over here and do a git push, and hopefully this time it will not fail and it will end up in GitHub. Sure enough, this one now says it's successfully pushed. So I can come over to my web browser and I can take a look at my repo, and we see I just updated that feature branch. Now, the cool thing to understand how this works is that I'm using a feature of GitHub Advanced Security that says we want to block commits for anything that contains secrets. And so that feature is turned on. And that's how Visual Studio and other tools like Visual Studio Code can protect you from accidentally sending the secret up to a public repo or just to your team. So now I've done that. What we need to do is have my team look at my changes. And so how we normally do that with GitHub is we'll do a pull request. I went ahead and already did that. Now all of my actions have run both for the pull request and for the application. And so with the first one, let's just go take a look at our podcast app and let's do a refresh on this page. And notice right away, we get that change, and that's one of the great things about GitHub Actions and the power of the cloud. We're able to use those scalable hosted runners that will run automatically for us and then have a deploy up into Azure. If we go take a look at Azure, you can see that I'm able to link up my deployment status. Here's my resource group with all of my different resources. We can come in here and take a look at deployments, and we can see that I was able to do a bunch of deployments right now automatically. And if we come back over here to the overview, we can see, for example, there's my API container app that is running in the new Azure Container App Service. So lots of great stuff to get out of this new release of Visual Studio, both on the front end with .NET MAUI, but also on the back end with Azure Container Apps. Now, one thing I wanted to show you before we wrap up here is, GitHub Actions continues to evolve and make life better, and a couple of great things coming out of that. First, we're able to set up a CI pipeline that's dedicated for working with MAUI. And if we go look at the results of this merge pull request, we'll see that we had two jobs, one that built Android and one that built iOS, using the awesome hosted runners provided by GitHub Actions. That's pretty awesome. Additionally, we're able to output the artifacts that you see on the screen. And then finally, you'll notice we're taking advantage of a new feature that's in public beta on GitHub, which is known as job summaries for actions. What you see here is that first is all the tests pass. So we have some unit tests that we run as a part of the pipeline, and we're able to use this job summary to display that information. And what you see here for this little bit of code is another action, which knows how to parse your unit test output and display with this nice display value here. And of course, if you had failures, they would show them as well as the successful tests. Right here, we've got this Android app is ready to go, and you'll also see that the iOS test ran and the iOS app is ready. And of course, it wouldn't be a proper MAUI demo without a dreamy picture of the Hawaiian Islands. So this is really great stuff that you have available to you. You could go take a look at Actions, and of course, anytime if you want to see what's going on with it, you can go into your workflows and you can take a look at the YAML that Visual Studio helped us get started. So if we look at the MAUI YAML file, we'll see that we've got this information to handle pushes, pulls, and we're able to install .NET 6 and install the necessary MAUI workload tools. As you've seen, the combination of Visual Studio and GitHub provides not only excellent Git tooling for development, but also helps you accelerate getting to Azure quickly by setting up your CI/CD workflows, building your multi-platform .NET MAUI app, and deploying your services targeting Azure services such as Azure Container Apps. Additionally, I showed you two new capabilities of GitHub Actions. GitHub Advanced Security with push protection to help prevent unwanted secrets from getting to the repos, and Actions job summaries, enabling new ways to append job information to your workflows, such as test result visualization and more. I encourage you to enable these on your repos today and start improving your CI/CD workflow experiences. There's a ton of work happening across Visual Studio and .NET that we couldn't possibly show you all today. I want to remind everyone that we are full steam ahead building the next version of .NET in the open. .NET 7 Preview 4 is available now, and previews drop every month until we release in November. If you haven't tried the preview, I encourage you to give it a try and give us your feedback. Download .NET 7 Preview 4 and try it out today. And finally, I'm excited to announce that .NET Conf 2022 will be November 8th through the 10th, where we will launch .NET 7. Like always, this 3-day virtual event will go deep into all things you can do with .NET. We will have tons of sessions from the product teams at Microsoft as well as the community. Keep an eye out for the call for content opening soon and learn more at .NETconf.net. Save the date. Thank you for tuning in today. We saw a lot of great stuff across mobile, desktop, web, and cloud development. We hope you give Visual Studio 2022 and .NET MAUI a try. On behalf of the .NET and Visual Studio teams, thank you and have a great conference.